Hey everyone, and welcome to Bright Bites. So, let's talk about a term that is, well, everywhere these days machine learning. It's powering our phones, our cars, even our Netflix queues. But what does it actually mean? Today, we're going to cut through all that hype and get right to what's really going on under the hood. All right, let's dive right in with the million-dollar question. You hear AI and machine learning thrown around all the time, sometimes even in the same sentence. So, are they the same thing? The short answer, not at all. And trust me, once you get this one difference, the whole field of AI starts to click into place. So let's break down this relationship. Probably the best way to picture it is to think of machine learning as AI's smartest kid. It's a super important part of the AI family for sure, but it's not the whole family. It's really just one, albeit incredibly powerful branch of this huge tree we call artificial intelligence. Okay, so let's zoom out to the big picture first. Artificial intelligence, or AI, this is the grand vision, right? It's the whole field of science that's trying to build machines that can think like us humans. Things like reasoning, solving tricky problems, maybe even being creative. It's a huge, ambitious goal. And this is where machine learning, or ML, enters the picture. It's not the destination itself, but it's one of the most powerful engines we have to get to that AI destination. And the core idea here is just, it's a total game changer. Instead of painstakingly writing millions of rules for a computer, we just feed it a mountain of data and let it figure out the patterns for itself. It actually learns from experience without us micromanaging every step. This slide really nails the difference. Think about it like this. AI is the whole self-driving car. The big goal is to get you from point A to point B safely, a really complex task. Machine learning, on the other hand, is a specific skill that car has learned. It's the part of the system that's been shown millions of images so it can do one thing perfectly: recognize a stop sign. ML is the specific skill that makes the broader AI goal possible. Okay, so how in the world does a machine actually learn anything? Well, it's not magic. It's really more like a set of playbooks. There are three main strategies that data scientists use to train a machine learning model. Let's take a look at them. First up, we've got supervised learning. This is probably the one you'll see the most. The idea is simple. You give the machine a boatload of data that's already been labeled with the correct answers. It's like giving it a giant flashcard deck. We show it thousands of pictures and say, this is a dog, this is a cat, this is a dog. It learns by example, making it perfect for things like classifying images or predicting future outcomes. A really great way to think about this is the game 20 questions. You know how it works, right? Every yes or no answer you get is basically a label. It helps you cross things off the list and get closer and closer to the right guess. Well, that's almost exactly how a supervised learning model works. It uses those labels to figure out the patterns and connect the dots. Next up is unsupervised learning. Now, this is where things get interesting because we take the training wheels off, we give the model a huge pile of data, but this time there are no labels, no answer key. We just tell it, go figure it out. Its entire job is to explore that data and find hidden patterns or natural groups on its own. It's amazing for things like finding different types of customers in your user base. I love this analogy. Imagine you put 100 people who love to read into a big room and say, okay, form book clubs. At first, it would be total chaos. But pretty soon, you'd see the people who love fantasy novels start to cluster together over here, and the history buffs would form a group over there. They create their own groups based on what they have in common. That is exactly what an unsupervised algorithm is doing with data. And the third playbook is reinforcement learning. This is all about learning by doing, through trial and error. You have a little algorithm called an agent, and you let it loose in a virtual environment. When it does something right, you give it a reward. When it messes up, you give it a penalty. It's how we train AIs to do things like play chess or control a robot arm. It just keeps trying things until it figures out the best strategy to maximize its rewards. Honestly, this is pretty much how we humans learn anything new. Think about studying for a big test. You take a practice exam, right? You see what you got wrong, you go back and study those specific topics, and you try again. It's that constant feedback loop of trying, failing, and adjusting that helps you get better. That's reinforcement learning in a nutshell. All right, so we've got the learning styles down, but how do you actually build one of these things from scratch? Well, it's not just a single step. It's more like following a recipe, with a few key ingredients in stages. So let's head into the ML kitchen and look at the 5 main steps. Step 1, you've got to collect your data. This is like gathering all your raw ingredients. Then, step 2, and this is a big one,
You have to pre-process it. This means cleaning it up because real-world data is always messy. Then comes the fun part, step 3, training the model. You feed it all that clean data and let it learn. But wait, you're not done. Step 4 is crucial, evaluation. You have to test it on data it's never seen before to make sure it actually works. And only if it passes that test do you move to the final step, 5, deployment, which is where you release it into the wild for a real application.
And I really want to double click on that data cleaning step because it's so important. People sometimes think it's a minor chore, but look at this stat from Gartner. Poor data quality is costing companies almost $13 million a year on average. That's insane. In the world of machine learning, that old saying, garbage in, garbage out, isn't just a friendly reminder. It is the law. Now, I know a lot of this can sound kind of abstract and technical. But the crazy thing is, you are already using machine learning every single day. It's running silently in the background of your life, in places you might not even expect. Just think about it. That show Netflix just knew you'd love, that's ML. The way your email magically filters out all the junk, yep, that's ML. Your smart assistant, the personalized ads you see, the traffic predictions on your map app, even the way Facebook automatically tags your friends in photos, it's all powered by machine learning. It's the invisible engine of the modern internet. To really get a feel for the incredible scale that we're talking about here, just look at this number, 160 billion. That's a B. Just let that sink in for a second. Any guesses what that could be? That's roughly how many transactions MasterCard's AI systems sift through every year to spot fraud. But here's the kicker. It does it in less than 50 milliseconds per transaction. That is literally faster than the blink of an eye. That's the mind-boggling speed and scale of machine learning working behind the scenes to keep our finances safe. But for all its power, and it is incredibly powerful, it's really important to remember that this isn't magic. It's just math. And because of that, it comes with some very real limitations, challenges, and some pretty serious ethical questions we absolutely have to talk about. You know, developers are always fighting these technical battles. Things like overfitting, which is basically when the model gets an A+ on the practice test but completely bombs the real exam because it just memorized the answers instead of learning the material. But honestly, the biggest, most difficult challenge isn't technical, it's human. It's bias. Because if the data we use to train these models is biased, then the model's predictions will be biased too. Period. And that really leaves us with the most important question we have to face as we build this technology. These machines are learning from data that we humans created. So we have to ask ourselves, what are our own biases, and are we accidentally teaching them to our machines? Making sure our models are fair and responsible, that's the real frontier in this field right now. And that's our whirlwind tour of what machine learning really means. I hope this helps clear things up. If it did and you want more explainers like this, do me a huge favor and hit that subscribe button for Bright Bites. And hey, share it with a friend. Thanks so much for watching. And you're definitely going to want to stick around because next time, we're going one level deeper. We're going to tackle the magic behind things like ChatGPT and break down how large language models actually work. You won't want to miss it. See you then.